Hi, let's understand what is a spherical capacitor. A spherical capacitor. Now, as the name suggests, it consists of sphere, spherical shell. Note it down, it's spherical shell. It's not a solid spherical surface, just a spherical shell. Okay, now it also, inside of it, there is also another spherical shell. It's considered an inside central point, and the radius of the small sphere is a, and this big sphere is definitely b. And we know that a is greater than, sorry, b is greater than a. Now let's take a Gaussian surface. Now what is Gaussian surface? A Gaussian surface is the surface where the, wait a second, before that we have to consider the charges in it, right? Inside the shell there is a positive charge, and outside the shell there is a negative charge. Okay, and this outside is connected to an earth. Okay, now this plus q charge will create a Gaussian surface. What is a Gaussian surface? It is very useful in solving and finding the like potential values. So it's just the space around which the electric field of this particular charge is measurable. Okay, so we consider that space. Now let's take the radius of this is r. Now we know that a is less than r is less than b, right? Done. Amazing. Now let's proceed. Now what is let's also understand that a charge of plus q will flow from the outer shell to earth. So your aim today is to understand this, and say why does the charge plus q charge will flow from the outer shell to the earth. This is the question that I'm going to raise to you. You have to answer it. Okay? Done. Now, let's derive the capacitance equation. First of all, derivation. For derivation, first check what we have to find. We have to find capacitance. You know that capacitance is equal to Q by V, right? Okay. First, what do you know about, from the first lesson, what do you know about this shell? We know the electric field of this particular spherical shell. What is it? It's Q 1 by 4 pi epsilon naught Q by R square, right? We know that electric field is equal to 1 by 4 pi epsilon naught Q by R square. Let's take this as equation number 1. Okay. Now, we also know that from second lesson, electric potential, we know that the the potential difference is negative integral of electric field dr, right? And what's the limit over here? Over here, the limit is from A to B, right? A to B, like from here to here, right? From this surface, right? So from A to B. And what is this? This is nothing but VB minus BA, right? Okay. Minus integral A B E dr. Let's consider that this particular big spherical surface is like at infinity. At infinity. Okay, literally at infinity. We know that the potential at infinity is definitely going to be zero, right? So this means potential at V is going to be zero. So what we left is VA is equal to minus mu is equal to integral all these things, right? Now we know that minus minus will get cancelled and all such things happen. Let me continue over here, okay? Continue over here. Now we know that we have VA. That is what we left with, right? So integral A to B E. Let's substitute this one here. Substitute 1. Okay. Now when we substitute, we get what? 1 by 4 epsilon naught. We take this side and we do all such things to get, like, let's do it. Let's do it. Let's keep 1 by 4 epsilon naught as k and q by r square into dr, right? I'm taking this and this outside and we get what? We get uh, k q integral a to b 1 by r square. Let's integrate it. While integrating, what will be the thing that we get, right? What is it? Q by 4 pi epsilon naught. When we apply the limits, we get what? We get 1 by a minus 1 by b. Is that right? Is that right? So I think you just have to integrate it, okay? Wait a second, guys. Wait a second. Let's don't leave that integration part. Let's do that also. We know that while we integrate, we just take this the side inverse kq ab a inverse dr. I'm integrating it, so I get what? R minus 1 so to R inverse, so 1 by R is what we get when integrating. So 1 by R, the limits are AB, KQ, right? Good. Now let's apply the limits. KQ, okay, 1 limit minus lower limit, right? Uh, so 1 by E minus 1 by B, right? Now when I do, we get what? We get Q B by A divided into K, right? K divided by A, right? Good. Now what is this? What is this? This is V. Now we got all of these things. Now the main aim is to find the capacitance value, right? Let's find it. We have VA and all such things. Let's find what is the capacitance value. You know that capacitance is equal to Q by V, right? So Q by V. What is V? V is nothing but K Q B minus A by BA or AB. Okay. Q will cancel. We get BA by K into B minus A. Let's substitute K value over here. So we get what? We get nothing but 1 by K is what? Just uh, 4 pi epsilon naught. Let's do it like so that we can memorize it easily. Okay, this is the equation for capacitance of a spherical conductor. Equation for capacitance of spherical conductor. Very important in JEE mains point of view. Okay, I guess I made it simple and very important because derivations are really important for J advanced, right? So let's do all those derivations step by step, the upcoming videos, and let's cherish learning. Okay, guys, bye.